back. So at a very high level, what am I hoping to cover in this course? And this is the minimum list, but this is all going to be expanded on depending on how much detail it seems worthwhile to go into. I'm going to start with the background and history of this whole project. Where did this come from? What kinds of things were myself and my colleagues thinking about back in 1986 when we first put this together? Then I'm going to talk about the D mode, the data processing mode of a cell. This is where you can view it as simply a piece of combinational logic. So how is that set up? How does that work? D mode is the mode that you're going to use most in using a cell, but it's not the really unique feature. The unique feature is the control mode, the C mode, where you're actually modifying the truth tables within a cell. And the interaction between D mode and C mode will be something that we call self-duality. And that's going to be a big topic that will get covered throughout all of this. Then I'll talk a little about implementations. How do you actually build a cell? What's the schematic for a cell look like? What have we done as far as implementations? What are some of the impediments and some of the goals in the future for implementation? Where do we see this going as far as longer term, large scale implementations of physical prototypes of the cell matrix? I'm going to talk about something called crystals. This is a way to tap into the single global signal in the system, which is a system-wide clock. And we can tap into that and use it to synchronize circuitry. Now, the cell matrix is normally asynchronous in nature, but we can synchronize our circuits by tapping into the system clock. And one way to do that is to use these things called crystals. Then we'll look at some simple C-mode operations for doing reads, writes, and copies of cells, being able to take the contents of one cell that's already been programmed and replicate it in another cell to create a copy of that first cell. If we can clone our cells like this, we can clone collections of cells and make copies of entire circuits. We can also modify them along the way, and that will take us off into the direction of general circuit building from within the system itself. And then I'm going to talk about wire building. Wire building is really the key to being able to build large-scale circuits because there are no wires in this system to begin with. All you have are cells, and you use cells to basically build wires. Being able to build wires remotely using other wires is a key to being able to manipulate the matrix from one point inside the system. And so we'll talk a lot about wire building, circuits for doing that, and then some tricks for doing it. Some Java classes that have been developed that you can download and use to create wire building sequences, which will let you do things like bootstrapping and so on. Then I'm going to talk about Medusa circuits. Medusa circuits are basically parallel wire building circuits and parallel cell configuration circuits. So when you're trying to do something like configure 1 trillion regions of your matrix to some default circuit, you don't want to spend 1 trillion time steps doing that. You'd like to do it in some sort of more efficient way. And a Medusa circuit is a way to do that. Then I'll talk about supercells, this idea of building large-scale blocks out of these low-level cell matrix cells to create basically a new type of cell that has more capabilities to it, where the capabilities can be customized in software based on the requirements of your project. So if you need a system that has fault tolerance, that has the ability to dynamically build communication networks based on certain criteria, maybe has built-in arithmetic units or DSP modules or whatever, you can put these all in a supercell of your own design and use that as a new atomic unit with the whole cell matrix architecture sitting underneath it as a lower level fabric. So I'll give some examples of supercells and we'll talk about some of the aspects of that. There are a lot of other things that will go on throughout all of this, but this is just sort of a high level hit list of some of the topics. So that's the 40,000 foot view of what these videos are going to cover, but there's going to be a lot more than that.